Hey guys, what's up? Today's video is going to be a little different. Today, I'm going to walk you through the design of a rear wing for Sabine, who's our Spec E30 race car that we're going to use at this fall's Grassroots Motorsports Ultimate Track Car Challenge. Alec and I got invited to participate. It's open class rules, and so we're going to put some aero on the car. We've designed and built a splitter that we've posted, so there's a video on our channel. We're going to go through, add a couple other little bits and pieces, but the rear wing is kind of the biggest piece. Now, huge disclaimer, I have never designed a rear wing for anything. So I'm going to be learning as we go. I've used a lot of reference material from others that have done this and have some great articles, and I'll put their links down in the doobly-doo below in the comments. If there's something that you see that we should modify or try or make the design better, again, please put your comments down in the doobly-doo below, and we'll be sure to read them. And at the end of this, if we like what we see, then we're going to prototype it up. We'll walk you through that process. If we don't, or I'm just not feeling it, this is a safety thing as well. And if I'm not comfortable with it, then we've got a fallback position that we may pull the trigger on. But anyways, so want to give you a little intro to this. It's going to get a little nerdy. Again, hopefully you enjoy it. If so, sit back, get comfortable, grab an adult beverage or three, and we'll get started. Well, as part of the design process, seeing as we've never designed a rear wing before, we wanted to go and do some research, see what other people are using on their E30s. There's a lot of different design styles and mounts, and so that was the first step. We've got little flip-up designs, we've got trunk-mounted designs, swan neck that attaches to the top. We've got solid uprights. We've got little spindly uprights, even more spindly uprights, and then finally fender mounted. So the one design that we kept seeing was the 9 Lives Racing airfoil. We liked the design. It was thick enough. It had a lot of data online as well, so we could go through and compare and see how much downforce this makes versus what we think we need. And so we decided to start there. So we were looking for just a few things. Really, it's all about downforce. There's drag, there's efficiency, there's all sorts of other things. But at the end of the day, we're just looking for downforce at somewhere between, call it 80 and 120 miles an hour. And this wing seemed to be making it, about 200 pounds of downforce at 10 degrees angle, which is about where we want to be. We've got a fairly small splitter up front, 3 to 4 inches in the front, and so we wanted to have something that didn't overpower the front. So we decided to start with this profile, and it was going to be the basis for our design. So here's the side profile. Pretty mild, thick enough, we believe, that we could build CAD around it and print this out. And so really the next step after this is to look at other wing profiles that were close to this. So once we decided on the 9 Lives profile to base our design on, we went on the web and found a really great reference site. I'll put the link down in the description below, and found this CH10 profile that looks pretty close to the 9 Lives profile. It also has a ton of data on it. It's been used on real airplanes. It's it's been around for a long time. It also looked like it was something that was thick enough, a fairly simple profile, something I could actually design in CAD, and then we can print it out and prototype. So from there, once we had the wing profile that we wanted, we moved into CAD, which I'll walk you through here. It's a little bit lengthy, but if you stick with me, I'll just describe the process I went through. I designed on the fly a little bit, but I'll walk you through that as we go along. Okay, so here we are in CAD. I use SolidWorks for most of my work. And so I'm just setting up the workspace here, getting everything ready. And then what's great about SolidWorks is you can bring in what's called an underlay. It's basically a picture behind the CAD model. And so I'm getting it sized exactly where I want it to be. I know this airfoil is going to be about 9.5 inches wide. And so I want to set this up to scale. So it's 1-to-1 scale as I start to do design work on it. So what you'll see here is I'm kind of getting everything situated. CAD a lot of times is just getting the model set up the way you want it in space, in 3D space. Getting everything scaled right, double checking everything. And then here I am, I'm starting to lay out using a tool called a spline, which is kind of a multi-point curve that you can manipulate pretty easily, so it's fairly free-form. You know, these airfoils are pretty free-form themselves, they're pretty organic. And so this tool makes it really easy to get a nice outline. And this outline will be the wing shape that I'll eventually take and manipulate later in the video to show you how I actually take it from a 2D sketch into a 3-dimensional part. And so now I'm gone through, I've gotten the profile, I've offset it by about 1/8 of an inch. That'll be my wall thickness of the wing itself. And I'm starting to drop in supports within this structure because the airfoil will need some structure inside that'll be printed to give it support. It won't be load bearing, but it also can't be floppy, if that makes sense. It can't flex a lot. And so I'm dropping these in, you'll see in a little bit. I'll hollow these out and then unite those with the outside edge to give it kind of a solid form. The other thing I'm looking at here as I'm dropping these in is each one of these will be hollow. And so the thinking is that although the printed part will be the airfoil, the actual structure, what actually is load bearing, will be these 4, maybe 5 rods that will support all the downforce. So if this thing is creating, let's say 200 pounds of downforce at speed, these hollow tubes, these hollow rods will support that load and flex but not fail, if that makes sense. And so I've added these in. I've done some calculations on what is the maximum stress these can take without failing, because obviously you don't want the rods to fail, the wing to fail. And the calculations show that I've got about a 1.5 times safety margin. So this thing would have to see 1.5 times the load that I expect it to see before the rods start to permanently bend and fail. All right, so now I've hollowed out those holes. This is like a little test piece. It's like a 1/4 inch wide. I may print this out and see what it looks like. See how the printer actually does it before I commit to something big. I've gone in, added some fillets to give it a little strength. And now I'm going back in and saying, okay, what would it take to then do larger sections? All right, so in this section, I'm getting pretty close actually to having one built out 6-inch section that I can run and do some calculations to see how long it'll take on my printer. Once I get this built out, I'll do a calculation in my prototype slicing software to see how long this will take, and then I can calculate how long it would take to build out the entire wing. All right, next, this is where I start to model out the tubes. So these will be almost 70 inches long. That's going to be the width of the wing. And so I start modeling these out. I have a couple of 1-inch tubes in there, 1.25 inch tube, 1/2 inch tube, and then at the very end, an 1/8 inch rod, which I think is probably going to be too small, but it's kind of where I'm starting right now. So the next little bit is just me modeling out these rods, and I'll start to drop these in to the model assembly later on. All right, so now The beauty about CAD is I've just renamed this file to be one of the little support pieces. This is, before this was a little printed piece, and now I'm going to use the outline so I don't have to remodel all this again. And it's going to be the actual aluminum piece. It's a spacer piece, essentially. And so a lot of this geometry I just don't need. I just need something that's solid with some holes in it. And so I've gone ahead and kind of deconstructed it, saved the file, and then you'll see here shortly where I go back in and I just put holes through what essentially is a solid 1/4 inch plate. So now I've taken that profile, it's not hollow anymore, it's solid, and now I'm basically putting holes through it. This will be a little spacer piece. I'm going to have a number of these in the middle that'll have what essentially is a piece that attaches to the uprights, and then I'll have 2 end pieces that the little rectangular side plates, end plates will attach to as well. So this is one of the end plates. So the rectangular side plates that go on the both sides of the wing will be attached to these 1/4 inch holes, and so I'm dropping those in. Those will get aligned here in a minute. I'll put holes through them, and then this plate is pretty well done. All right, next I'm going to use the exact same profile, exact same part. I just renamed it again. Again, the beauty of CAD is being able to reuse bits and pieces from other CAD models. And I'm starting to build out the 2 pieces. Again, this is 1/4 inch aluminum. These 2 plates then will attach to the 2 uprights that are attached to the trunk. And so I'm building these out. These will be machined. And you can start to see I'm going to start to place these in the model, and then I'll start to build out the final assembly here in a minute. Okay, so the first pieces are starting to come together. I've got the end plate on one of the profiles, the printed profiles. Now I'm going to start bringing in all of the aluminum tubes and getting those all mated up. In CAD, there's a thing you call mating conditions. Basically, you can align things. It's a fancy word for aligning. But basically, you can align it based on a number of things, like the face-to-face. Here I'm doing face-to-face to make sure it's even with the outside, and then I'm doing center-to-center. So I'll bring all of these in. It's also a good way for me to check clearances to make sure I have enough clearance between the hole and these aluminum tubes. You don't want it to be the exact same dimensions, because then you'll never be able to slide it in if there's any interference. And so you leave a little bit of clearance there, maybe 10 thousandths, 20 thousandths clearance, something like that. And then you can put all this together virtually, check it out, and then when you build it, obviously you're putting it together for real. All right, now I've checked everything. All the clearances look great. And now I'm going to start bringing in every part that I've modeled, and this will be the final CAD assembly. So there's the rods. Each one of these sections is going to be printed. So I'm bringing all those in, plus the spacers, the aluminum end plates, and there is the final wing. Well, if you made it this far, appreciate it. Hope you learned a few things.
Hey guys, what's up? Today's the big unveiling of our new rear wing. So Alec, 3, 2, 1. Yeah. So let's talk. Okay, so now let's talk about our new rear wing. So as the video showed previously, we went through the whole design process. And at the end of the design process, Alec and I had a long discussion. And for a number of reasons, we decided we're not going to prototype that wing. Although cool, and it was a lot of fun, there was really a couple of factors. Number one, it got heavy. And it got heavy compared to what's available on the market. Number two, my little prototype machine would have to run for 40 days straight. I have other jobs that need to get done on that prototype machine, so I can't put it to use for 40 days. And finally, I don't trust the numbers. This car will be traveling somewhere over 100 miles an hour, and the last thing I want is a rear wing failure. So with all of that, we decided maybe later we'll prototype it, we'll do some more calculations, we'll get other people that actually know what they're doing to help us out. But for now, we decided to enact Plan B, and this is Plan B. So Plan B is a 9 lives rear wang. So I had a conversation with Johnny, and if you don't know Johnny, he owns 9 Lives Racing. They've been in the game for a long time. They've got rear wings on just about every winning car in most amateur and even some pro events. And so after talking to him, we decided to go ahead and pull the trigger on one of his products, which is this rear wang. It's an amazing product, really great value. Aluminum extrusion, comes with side plates, the uprights, all the hardware. Super easy to install. In fact, we did an install video that we'll probably post here in the next couple of weeks. And so we decided to go ahead and install this and test it out. We know we'll have success with this. We know what the numbers that this thing generates, and it's a known. And so we're going to take it out, do some testing, and this is what we're going to run at the Grassroots Motorsports UTCC event in October. So that's the big update. Maybe in the future we come back to the other design that we did, and we'll see. But for now, we're going to go with this.